Welcome to The Explainer. Today we are tackling a really fascinating challenge in the world of modern technology. We're diving into adversarial testing for generative AI. We're basically going to explore this proactive, almost ethical hacker-style approach of intentionally trying to break generative models. Why? Because breaking them in the lab is exactly how we make them safer and way more robust out in the real world.
It really all starts with this one major question. How do we actually know an AI is safe before we launch it? Just think about it for a second. We're dealing with these incredibly powerful models, but how do we find their blind spots before the public does? How do we absolutely ensure they aren't going to produce harmful or unsafe outputs? Well, the answer lies in stress testing them to their absolute limits. So here is our roadmap for getting there. We're going to cover what adversarial testing actually is, and then walk through a 4-step workflow: identifying inputs, crafting test datasets, generating and annotating, and finally reporting and mitigating. Then we'll wrap up with what this means for building safer AI. Let's jump right in. Section 1, what is adversarial testing? Or, as I like to call it, breaking things to build them better. Okay, let's break down this definition. Adversarial testing is the process of systematically evaluating a machine learning model, but with the specific intent of learning how it behaves when you feed it malicious or inadvertently harmful input. Now, in standard testing, you're usually just checking to see if the model does what it's supposed to do, right? But here, you are proactively giving it the exact data that is most likely to cause a problem. You're actively trying to force the model to fail in an unsafe manner so you can catch those safety policy violations early on. Now, you might be wondering, how does a query actually become adversarial? It generally falls into 2 buckets. First, you've got explicitly adversarial queries. These are obvious. They use policy-violating language, or they actively try to trick the model into saying something offensive. But then you have implicitly adversarial queries. These are tricky because they seem totally innocuous on the surface, but they touch on culturally sensitive or potentially harmful topics, things like demographics, health, or finance. We absolutely have to test both types. All right, moving to section 2, step 1 of our workflow, identifying inputs. This is where we set the boundaries for testing. Just to give you a quick visual map, adversarial testing follows a 4-part workflow that's actually pretty similar to standard model evaluation. We're going to look at these 4 steps closely, starting right now with step 1. So step 1. Listen, thoughtful inputs literally dictate the success of your entire stress test. Your inputs have to be incredibly diverse. First, you look at product policy and failure modes. For instance, Google has a generative AI prohibited use policy. Every restriction in there needs a safeguard, and those form your baseline. Next, consider use cases and edge cases, so the normal ways people use it, plus the really weird, unexpected ways. Then there's lexical diversity. You can't just use the same sentence structure over and over. You need different lengths, wide vocabularies, direct versus indirect phrasing. And finally, semantic diversity ensures you're covering a massive range of global topics and sensitive identities. Let's move to section 3, step 2 of the workflow, crafting test datasets. This is where we build the ultimate stress test. There is a massive difference in how we create datasets here. Standard testing uses what we call in-distribution data. That's just the normal, expected stuff the model sees every single day. But for adversarial tests, we want out-of-distribution edge cases. We are deliberately selecting data that is specifically designed to push the model way outside its comfort zone and test the very edges of our safety policies. So where on earth do we get this highly specific data? Well, you can start by finding existing academic benchmarks to establish a baseline. But honestly, those usually aren't enough for specific product failure modes. So teams often have to create them. They'll manually build a tiny seed dataset, maybe a couple dozen examples, and then they'll scale it up using data synthesis tools like BigQuery data frames or other LLMs to create a massive customized testing suite.
If you're building these datasets, there are some crucial best practices. First, make it mimic real production data closely while targeting specific policy violations. Here's the real secret sauce, though. You have to use creative phrasing. Basic, highly toxic language is going to get caught instantly by simple filters. It's literally like trying to sneak through the front door with a bullhorn. The real trick is crafting implicitly adversarial inputs that bypass those easy filters. Also, vary your tone, and whatever you do, avoid noisy overlapping labels. If an example is both hate speech and obscenity, it just creates noise and confuses the evaluation systems. Keep it clean and highly targeted.
Okay, section 4, step 3 of the workflow, generating and annotating, or basically grading the model's performance. So you feed your crafty dataset into the model, and it spits out outputs. Now you have to grade them. You have 2 main options here. First are safety classifiers. These are great because they're automatic and super fast, but they really struggle with nuance. So for complex, highly subjective issues like hate speech, you absolutely need human raters. They are essential. But remember, humans have personal backgrounds and beliefs, meaning two people might grade the exact same output differently. Because of this, you have to equip your human raters with incredibly strict guidelines to manage that bias and ensure the grading stays consistent.
Which brings us to Section 5, Step 4 of the workflow, reporting and mitigating. This is where we close the loop.
All that grading isn't just for a nice-looking report. The computed safety rates and failure visualizations directly guide actual mitigation. The data tells your engineers exactly where they need to fine-tune the model, where to build new safeguards, or where to just implement a hard filter or block list. Ultimately, these results are what you hand over to the stakeholders to inform the final product launch decisions. It's how you prove if the AI is truly ready for the real world.
Finally, Section 6, Building Safer Generative AI. This is all about the ongoing commitment to responsible AI. There's a quote from the source material that I think perfectly wraps up everything we've discussed today. Adversarial testing can help teams improve models and products by exposing current failures to guide mitigation pathways. This isn't just an extra step, it is a foundational best practice for responsible AI development. By deliberately and aggressively trying to break these systems in a safe environment, we expose their weaknesses before they can cause actual harm.
So I want to leave you with a thought. Applying this ethical hacker mindset isn't just a job for AI engineers. It's a critical approach for anyone building complex technology. What assumptions about your own systems, your own safety policies, or your users do you need to intentionally stress test today? Think about it. Thanks for joining us for this explainer, and I hope this dive into adversarial testing gave you some powerful new tools to build safer, better products.